Excited about this session. I actually did this session, or an older version of it, in 2019. And we haven't really done anything since then on API Gateway, and so I was super excited to bring this back. How many of y'all are using API Gateway now? Okay, several of you. This is really exciting. How many of y'all are exploring it? Okay. Yeah, and using and exploring. Check that out, okay? Very cool. Well, first of all, let me tell you a little bit about who I am. My name is Eric Johnson. I'm a principal DA for serverless at AWS. I live, eat, and breathe serverless. And it's interesting, when I came to work for AWS, this was 5 years ago. I just passed my 5-year mark. And I want to apologize right now. I'm going to cough in the mic. I'm going to try not to, but it's going to happen. Sorry, group. You know, I'm having the reinvent flu, I guess is what we call it. That's what my wife calls it. It's just a cold, whatever. But when I came in, they asked me, they said, what's the most challenging service for you? And I mean, it didn't even take a moment. I was like, API Gateway. That's hard. It's hard stuff. So they said, great, learn it and teach it. So that's what I've been doing. I learned API Gateway. If you've ever seen it, I have 2 series out called Happy Little APIs. At one point, I even wore the Bob Ross wig, Happy Little APIs. So we had a lot of fun with that, but I love it. I've been a developer for 30 years. I'm a solutions architect for 10 plus years. I am an infrastructure as code freak. I love, I've been known to wear the Sam Squirrel costume. That's how much I love Sam and those kinds of things. I am a father of 5. That is not a typo. And I am a drummer. That used to say musician, but people are like, really? Drummer and musician? Maybe not. So now it says drummer. And finally, I'm a foodie. How many of y'all have heard me speak before? Okay, a couple of you. All right, well, I'm sorry. You have to hear the rules again, okay? There are some rules when I talk, because rules is probably a strong term, but these are guidelines for you, okay? So when I'm talking, the first rule is this. This is any number I want it to be. Okay, I'm going to hold this up, and I may say 7, I may say 14. It's what I'm saying instead of what I'm holding up. This always gets me in trouble, because I do. Everybody holds up and goes, there's 5 of us. Oh, I'm the only one that can go, there's 392 of us. Okay? So I go into a restaurant and I'll say, hey, table for 7, and I'm alone at the bar. So you got to hear what I'm saying. I can get to 4 if I take my shoes off, but it gets weird for everybody. Okay? So we're not going to do that. All right, the second is these are quotes, not apostrophes, and I know that. Okay, but this looks better than this. Okay? Every time I do this, someone says, is he doing a bunny? I'm not, unless I am. It's contextual, right? And the final rule is these are thumbs, because this will get you beat up. Okay? So that's what we deal with, right? So those are the rules that'll help you understand who I am. I was not born, let me rephrase that. I was born this way. I did not wake up this way this morning. That would be odd. That'd be really, you'd be like, man, he's really strong to be here to talk. I wouldn't be here talking to you. I'd be somewhere coping, right? So I was born this way. I'm very comfortable with one-finger jokes. However, if that makes you uncomfortable, I'm also comfortable with that. So either way, I'm good. But I appreciate you caring. So, all right, so let's get started. We're actually going to cover quite a bit. And today what this is the literal title of the session says, I didn't know API Gateway did that. And it's going to be a laundry list of things that you kind of go, oh, I didn't know. Or, hey, did you know? So we're going to kind of roll through these. So the first thing we're going to talk about is what is an API? Second thing we're going to do is we're going to kind of get into API Gateway itself and talk about some of the integration patterns, things like that. And the third is we're going to get into these features that are beyond the front door when we think about API. Excuse me. All right, so let's get started. So what is an API? Well, a lot of you raised your hand for API Gateway. A lot of you are exploring this. So you probably know, but I want to make sure that as we're talking about it, that we're kind of talking about the same thing that we understand. So API, what it looks like without an API, it's kind of the best way we can explain it, is if you don't have an API, then your client is usually trying to talk to your services directly. SDK from the front end, and there's some disadvantages to that. What you run into is you have possible overexposure. You're having to handle security at your services, things like that. All security is at the services. All routing logic is maintained at the client. So what you end up doing is you have to tell your client, oh, if you want this, you have to do this. There's a lot of logic there. And maintaining multiple versions of services can be complex. And come on, we don't really do this anymore. But sometimes I see it. It's like, well, why are we not doing that? Or why are we not doing this? When we throw in an API, this is this abstracted layer called the application programming interface. It isolates the underlying implementation. It abstracts the contract into this layer. It reduces exposure to your services, and it simplifies the interface, right? So it's very common for us to have an API when we're talking, and we call it the front door to our services. This is what protects our services. All right, so when we look at this, you can see the routing here comes through, and you hit your API, and then your API knows based on the path usually, if it's a standard REST API, where to route this to. And the nice thing about this is we can have a lot of different routes behind this, and your client doesn't care. It just hits this one endpoint with maybe some pathing in it, and it says, and you may point that to a whole different organization. But the API gives you this ability to say, hey, I'm going to split that up, and this is really handy when you have multiple teams building things. I can point it behind there, and my client doesn't have to care. The contract remains between the API and the client. All right, so when we talk about protocols for APIs, how do they communicate? Right, this is protocols. It's what do they use to communicate? We have GraphQL. Anybody using GraphQL now? Okay, very cool. We have REST. REST is still the most popular protocol on the internet. We have WebSockets, that's gaining a lot of ground. We have SOAP, that's actually an older one. Anybody still using SOAP? All right, I just want to apologize to you. No, I'm not apologizing, I didn't do it to you. I want to feel sorry for you together. So, yeah, it's rough, right? And then we have RPC and we have gRPC. With API Gateway, okay, as we climb in and talk about API Gateway, we kind of limit those, but we'll talk about some other things that handle those. So API Gateway, if you're not familiar with it, like I said, most of you raise your hands, but just so you know, API Gateway is our managed API Gateway service. It is a front door, right? And we have several options when you when you want to build a front door. You can do ALB, you can do app sync, different things like that. API Gateway has a very specific service or purpose, right? And for us, API Gateway is built to handle REST and WebSockets. Those are the two protocols, and if you know, according to the Postman State of the API report in 2023, 86% of the internet still uses REST APIs. So it's still in use, right? So we're still using that. So we want to be able to handle this. It's a very common pattern. Excuse me. However, if you are looking to use some of these other protocols, we've got you covered. You can see AppSync will do GraphQL. AWS IoT Core can handle WebSockets as well as API Gateway. And I have some thoughts on that. If you're looking to kind of figure out how you want to do your WebSockets, talk to me. But it basically comes down to this. I'm going to give you it in a nutshell. API Gateway's WebSocket is all the tools are there for you to build your own implementation. You can get really customized with it. Okay? So a lot of our companies are building like SaaS and things out of that. IoT Core, on the other hand, is like, boom, there's a box, here's everything you need, you can use it. Right, so there are two different purposes. One's to just kind of have out-of-the-box ready IoT or WebSockets that handles your topics and subscriptions and things like that. The other is build it yourself, here's all the tools you need, right? So if you look at serverless land or serverless video, the two products that our team has built to kind of show event-driven architecture, we use WebSockets because it has everything we need out of the box. I'm sorry, I didn't mean WebSockets, I meant IoT Core for our WebSockets. And finally, if you want to look at, you still need to handle SOAP, RPC, or gRPC, you can go to an Elastic Load Balancer. All right, so there's two types of Amazon API Gateway APIs. And we've had people say flavors, versions, different things like that. Now, I'm going to be right up front with you. Sometimes the names are a little confusing. Okay, but here are the names. We have our REST API, which is a REST API, and the protocols are REST and WebSockets. We have our HTTP API, which is a REST API. Everybody with me? And it uses the HTTP API. Now, really, if you think about these, the REST API is more of a full featured service. So they're a little different. but both are HTTP-based APIs. And this, I know this can be a little confusing. But they're both HTTP-based. We just call them two different names. So as we go through the services, some of your services or some of the features and things like that will be supported by REST. Some will be supported by HTTP. Some will be supported by both. So I've created a little kind of a legend at the top that will show you as we're going through there. And I usually refer to it, but if you don't see it, you can look up on the top right, and it'll tell you which service supports this. Every once in a while, you'll see an asterisk, and I'll call that out. All right, so continuing to talk about Amazon API Gateway, let's talk about some of the types of APIs you can build. Now, I think this is somewhere where people get a little confused, so I'm going to try to clear this up. So the first thing we have is what's called a regional API. And this is supported by both REST and HTTP. And in reality, all APIs are regional. Okay? They are spun up in a specific region. This API is in US West 2, EU West 1, whatever. All APIs are regional. That's how we do it. Okay? But we'll talk about, we also have a thing, you can see here, this is the like I said, this is the regional API. This allows you to, you can have, so this shows here, it says this is applications and services in the same region can hit this endpoint. But it's not limited to that. I want to be clear. It's like, well, I'm sorry, you're outside of the region. You can't talk to me. It just means they have to go further. So if this is a US West 2 region, and you're calling from Frankfurt, Germany, it's a little bit longer of a call, right? So you kind of want to move those APIs closer to your clients, right? And so for that, we have a thing called the edge-based or edge-optimized APIs. Now this one I really want to take a moment and explain. Now this is in REST API only. Now what this does is it creates a CloudFront distribution network for you. Okay? And you're like, wow, it's great. It is great, okay? But here's the thing. What it's doing is it's bringing what we call POPs, or point of presence, closer to your client. So if I'm using an edge optimized, it'll be on top of a regional API. So my API endpoint might be in US West 2, but if I'm in Frankfurt, Germany, it will call that closer point of presence. Then it'll route through the Amazon backbone. Okay, it doesn't move your API closer, it just gets them on our private network much faster. So they're not going through the network. So hopefully that makes sense. But what I want to point out is this, again, this is API Gateway Managed CloudFront. It's edge access to the Amazon network, but it does not include edge-based caching. And I think this is where some people get confused. Right? So the caching, you can add caching, and we'll see it in a minute, you can do API Gateway Managed Caching, but that's regional, okay? It's not at CloudFront. If you want CloudFront caching at the edge, and most likely you do, okay, then you want to do your own CloudFront, okay? It's not too terribly hard to set up, and I've got some examples of it. But what you do is you set up a regional API endpoint, and you say, I want this regional API endpoint, and then I'm going to do a CloudFront distribution, and I'll put that regional as my origin for that. And then I can have, and it's kind of transparent because it says, okay, I'll read the caching headers from the API gateway to set the caching, the time to live, different things like that in CloudFront. And that way you have, number one, you have caching at the edge, and number two, you have points of presence at the edge. All right, so that's really important to understand. Where this comes in really handy, you're probably looking at, well, why are you even telling us about this, Eric? Where this comes in really handy is if I need an API that I can't cache, the data's too hot, right? I can't cache that data because it's constantly changing, but I need to get them on the network and get them to this as fast as possible, and I don't want to sync that data all over the world. This comes in really handy. Right? So it doesn't cache it, but it does get you quicker access to the endpoint. So hopefully that makes good sense there. All right, the next type of API we have is a private API. Now, this is not to be confused with a private integration. We'll talk about that in a moment. A private API is specifically to say this API is only available to people in a VPC. It locks it down. I can't just go to the internet and hit this API. It's locked down with resource policies inside the VPC. And so this is what a lot of companies use internally to talk to each other and to pass data around. Again, should be confused with a private integration, which is a feature that we'll talk about in a little bit. All right, so we're going to pause for a minute, and I want to talk about RPS and burst. I have seen so many people write documents on this and explain this, and 99% of the time, including some of the ones I've done in my past, are wrong. This is a hard concept to understand, or hopefully I'm going to clarify it. Okay, when we talk about, and we'll talk about burst and caching and things like that a little bit later, but I want to do this early to kind of make sure we understand it as it applies to some of the features and things we're talking about. When you use API Gateway, REST or HTTP, you get a cache and a burst. I'm sorry, now I'm just making up things. You get an RPS, which means request per second, and you get a burst, right? And so these are two different things. So, and the hard codes, let's bring this in here. The burst is the number of concurrent starts API Gateway supports, right? And it has a hard maximum of 5,000. Now, it's important to understand that this maximum is for all API endpoints within a region within an account, not for one API endpoint. So if I've got 33 production business API endpoints in one account, I'm throttling myself pretty hard, okay? So, and if you want to talk to me outside sometime, we could talk about how one production per one account is a really good idea, okay? But, so burst is how many concurrent, and again, I want to stress this is concurrent. That means if all those requests came in at the exact same millisecond, we can handle 5,000, boom, right off the bat, okay? Now, the next part of this is what we call the RPS. Okay, I drew this pipe myself. I'm pretty proud of it. Okay, the RPS is the speed API Gateway refills the bucket. Okay, and it has a soft max of 10,000. Okay, so what happens is, back to our scenario, if we have 5,000 requests come in immediately, then boom, those are gone. Then API Gateway's going, okay, fill more in, and it can do up to 10,000 in that. That includes the original 5,000, okay? So over a second, you can only do 10,000 per second, but you can handle 5,000 at the exact same time. A lot of times I see people configure this so that they say, okay, we're going to set our max, our RPS at 5,000 and our burst at 10. Well, that doesn't make any sense, because while we may be able to handle 5,000 at the same moment, why we set our burst, first of all, that's over our max, right? Your burst should always be less than your RPS. Okay, so just keep that in mind. So your burst should be, that's how fast we can handle at the same time. RPS is how fast we can fill it. Hopefully that makes sense. It was really funny as I was digging through this. I had to go through and get a lot of people's opinions, and I went back to one of the guys who actually built this. I said, is this right? He goes, yeah, that's right. I said, okay, because I've got it wrong a lot. So you're getting it right. Until next year, and I go, yeah, I had it wrong. No, I'm saying this is right. So, okay. So that's important to understand as we start walking through things. All right, so we're actually going to, as we're talking about, this is still part of API Gateway. When we talk about integration types, all right, so these integration types in API Gateway, there's 5 different kinds, right? You have the Lambda function, you have the mock, you have a VPC link, an AWS service, and an HTTP. So let's look at what these look like. And it's really funny, you're like, okay, I have a Lambda function, and I have an AWS service, but hold on, wait a minute, Eric. Lambda is an AWS service. So I know. So there's 2 different ways to connect to a Lambda function. So let's talk about that. So the first connection we have is a Lambda function, what we call a proxy. And here's how this works. When a client makes a request to an API gateway, and it is using a proxy, what we will do is we will take the context, or we will take the data in the body, we will wrap some context around it, right? Connection time, connection requests, some different things like that API gateway throws in there. And then we will pass it to the Lambda function. And we will give them the event, which is all the pertinent data that came in on the request, and we will give them the context, right? So what happens is when we return this, and this is really important to understand, is this is sent back and API gateway doesn't do anything to it. It literally says, hey, here you go. So that means that you have to set your headers, your header names, your status code, things like that in the integration, in the Lambda function behind the scenes, or behind as the integration. So that's important to understand. However, you notice this is supported by REST and HTTP, or the HTTP APIs, but HTTP has a little asterisk there. So with HTTP, stay with me. HTTP has the ability to do a second payload. We have two types of payloads. One is kind of our older version, which matches REST, and two is our newer version. If you're using payload 1, then it's going to work just like REST API. But if you're using payload 2, then it actually uses some, I'll say magic, but some algorithms to figure out your status code, your headers, your things like that. HTTP API will handle that for you and pass that through. But it still doesn't affect the body. You can't change the body at the API gateway level. And you may be looking at me going, Eric, why would I try to change the body? Well, we'll get into that in a little bit, because you can do some fun things with REST and with API gateways. All right, so that's the proxy. So if you go in here, so this is the API HTTP, like I was saying. If I use payload version 2, then if I just kick back the text, this is my response, hello from Lambda, the HTTP APIs will know, okay, well, this is the status code 200 because I got a 200 from the Lambda. I'm going to go ahead and wrap the body and take care of that for you. I'll pass any headers. It takes care of all that for you. So it's really cool. So if you're just building a simple API, HTTP API is probably the way to go. In fact, my general advice is, and I want to be real careful with this because sometimes migrating can be kind of tough, but if you don't ever think you're going to need the features we're talking about, start with HTTP API. It's cheaper. It's cheaper and it'll work great. Excuse me. All right, so let's talk about a Lambda function direct integration, or as an AWS service. Now this is where we can get really fun and we can do some cool things, right? So what happens is when a request comes in, we can then apply what we call VTL, or velocity templating language, to the request. That means we can change that. We can transform that request, even in the body, the headers, whatever. Now this is REST only. And then so you can see the transform request looks much different. Then it goes to the integration in the Lambda function. The Lambda function kicks out a response, and we can change that as well. Okay, we can add to it, change it, modify things. So if we have multiple backends, we need to add a header that always comes out regardless. We can throw that header in, we can do all kinds of things. So that's a direct integration. However, it takes a little configuration. VTL, I'm not gonna lie, it's not necessarily for the faint of heart. It can be, anybody doing VTL now? Okay, do you love it? No. Okay, no, I heard a strong no down here, okay. Yeah. The thing about it is, and we'll talk more about it in a little bit, it's interesting. All right, so that's a proxy. So here's what a VTL transformation looks like, though, just so you can see it. You say, okay, your first name's John. This is the request coming in. First name John, last name Doe, got a phone number, got a city, got a state, and then a favorite pizza, which is actually incorrect, because pineapple should never be on pizza, right? So that comes in. So what we're going to do is, in our transformation, we'll go ahead and change, combine the name, we'll break the address out, fix that up, and then we'll correct the answer they gave wrong for the pizza, right? And we'll change that to pepperoni. So you can modify that as it's coming through VTL, okay? All right, so if you take that same thing, now you probably wouldn't do that with a Lambda function because that's compute, right? And you could do that all in the compute. It's like, why do we do that? But here's where it gets really cool. Okay, you can apply this to AWS services, and DynamoDB is a really good example. DynamoDB is an API endpoint, right? And so I can, and API Gateway will take care of my signing and all the headers and stuff like that to talk to DynamoDB. So I can transform a request that's coming in. I can write it directly to DynamoDB. I can also read directly from DynamoDB. I can make a request and get data back. Because VTL lets me take that and transform what that looks like so that can work, right? And so we do this. Anybody play around with serverless video or seen that yet? Okay, a couple of you. All right, so serverless video, if you want to grab this QR code, it's also at s12d.com video. We do a lot of this, and this is a new project we built to kind of show how event-driven architecture works. And so we're using serverless video, and so I'm going to show you some examples. Now, the VTL might be kind of small, but I've got them blown up after. I'm going to show you the whole thing. So first of all, this is an example of a request coming in for maybe a video, okay? So you can see here where I've got, using VTL, I've got some power to I can do some looping, I can do some if-thens, I can do all kinds of things to change the request. And this is the response itself, and I'll blow that up just a bit. You can see here, if the root has the last evaluation, okay, in this particular example, I'm adding, this is pagination from DynamoDB. I'm looking to see if it has the last key, and if it does, we'll pass it through. And then I'm also doing some looping to say, okay, however many of these you send back to me, I'm going to loop through and structure my data accordingly, right? So now, you can kind of see, yeah, VTL may be hard. You're like, why would I do that with a Lambda function? But if I had to build something, and if you remember, just a moment ago I said S12D, that's a URL shortener that we use in our serverless team, and actually all over Amazon now. You probably saw it in some other presentations. That particular application is nothing but API Gateway and DynamoDB. We use some, well, that's not true. We use CloudFront, and then we use some streaming off CloudFront. There is no compute. We're routing, even the authorization, we're handling it all in there. And it is wicked fast, and it is wildly stable because we don't ever update code. And let me tell you something, the most liable, frail part of an application is Eric Johnson's code, okay? My card, business card says principal developer advocate, but that's because they said that's what they had to call me. Really, I'm an architect, I'm a hack developer. You don't want me, if you have me developing for you, you're pretty desperate, right? So this idea is, I'm able to build this application, and I built that, the whole S12D, I built that as a proof of concept. Hey, can it be done? Yeah, it can be done. So just some things to think about. I'm not saying you should all go out and build everything in VTL now, but just think about the power, okay? All right, so this is REST. HTTP also has the ability to do some integrations. These are custom built into HTTP, and it's just these 5 services. But you can directly connect to the AWS app config, to Amazon Event Bridge. You want to drop stuff on Event Bridge, Simple Queue. One of my favorites is the step functions. I can connect API Gateway directly to a step function, and I can do a sync or async launch of that step functions, and I can do a lot. I love step functions. That's my go-to. Before I even use a Lambda function, I use a step function. If I need a Lambda function, I have the step functions invoke it. And then, of course, Amazon Kinesis if you're doing a front end on that. And with HTTP API, you get some power for transformations. It's actually done in both. You can do parameter mapping, where you can actually take and override existing values. It's not as powerful as VTL, but it does give you some of that power to do that. And again, this is also supported in REST or HTTP. Okay, so the other type of integration that we have is the HTTP integration. What does this mean? This means that basically you put your Amazon API Gateway endpoint, this is REST or HTTP, in front of anything out in the wild. This is kind of cool because before I was working at AWS, I had a company that needed to hit Google location, right? But we needed to stay within the parameters of what Google wanted to stay in, and so we needed a proxy to it. So we used API Gateway. And so my folks put, my company, or, it was like navigation.mycompany.com, and then it added any security headers I needed to it, and then it sent it. And using throttling and caching and different things like that, and API keys, I could minimize, I could stay within all the licensing that we need to stay in. So this was a proxy, and you can proxy all kinds of things with this. We're doing something really cool with serverless video where we're calling out to Adobe to do updates to an image, and they're sending it back to us. I think we're actually going to build and use this as a proxy because we want to keep that internal. We don't need everybody knowing our endpoints, so it's a good way to do that. All right, mock integrations is the last integration we're going to talk about. The mock integration is super cool. This is just literally, and this is supported just by REST. We'll get to HTTP in a moment. And this allows you don't need an integration. This is great for pre-flight. If you're using, you need to do an options response. You can do this. And we have some checks and buttons in API Gateway that'll actually automatically do this for you. It'll set up the mock integration. But it means you don't have to do anything to it. You don't have to have an integration behind it. You can just say, hey, if someone calls for this option, you respond with these headers and this, to allow, and then, to basically take care of cores. So let me take a pause for a moment. I said this several years ago, and it's been well quoted, but I'm going to say it again today. If cores had a face, I'd punch it in the nose. I'm dead serious. Raise your hand if you love cores. Yeah, a bunch of hands. Oh, no. No, I'm like, there it is, he loves cores. Cores is hard. And that's, we want to blame API Gateway, we want to blame our API stuff, but it's a browser thing, right? It's enforced at the browser, and it's hard. So we do our best to try to help you. If you struggle with cores, I built a tool a while back. This is a shameless plug, but it's called cores.serverlessland.com, and you tell it your cores needs, and it'll generate all the SAM for you for your deployments to do your cores for that. Because, cores is just, ugh. I'd rather go to the dentist than configure cores. All right, so mock integrations helps you with that. The same thing in HTTP API, we have a mock pre-flight. And what this does is it kind of evaluates based on what your Lambda function is doing and things like that. It will create you don't actually see it, but it will create the mock response for you. HTTP API kind of just does a lot out of the box for you in that respect. All right, so I said earlier we talked about private APIs. This is that private integration. Okay, and what this allows you to do is things that are in a VPC you can still connect to using API Gateway. Now sometimes you need a VPC link and a network load balancer to connect to it, and so your API Gateway through a VPC link connects to a network load balancer, and then you can connect to ECS or EC2, anything in there, even including direct connections to your on-premises. And this is really handy because you can keep your stuff in a private subnet in your API or in your VPC. You can tell I do serverless. I can't even spell VPC. I rarely have to work with them, but sometimes. And so when you have to do that, your API Gateway can connect to that. What's really cool is with the HTTP API, we did the same thing. Yeah, we're going to let you do that, but you can actually go directly to an application load balancer as well, including a network load balancer, or you can use the AWS Cloud Map, which is really handy if you're trying to connect to container instances behind there. You can do some filtering. There's a lot of power built into that. Okay, so that kind of covers the API Gateway, what we're used to, the integrations. Now I want to climb into API Gateway beyond the front door. Excuse me. And these are features that when I tell people this, they go, I had no idea. And these are the features that really honestly make API Gateway worth it. I mean, it does a lot before that, but these are the ones that you go, oh, okay, I should be taking advantage of that. Yeah, you should, right? So let's jump into these. All right, so the first one is authorization. Okay, this is pretty simple. Hopefully all y'all are doing authorization. What we see a lot is we see pass-throughs and the people are handing authorization at their actual servers or at the integration, and that's really not needed. If you run your authorization at your API endpoint, then you're doing it one time, and you're not having to do that at every endpoint. So you want your authorization to happen here. There's multiple types of authorization, obviously open, which is not really a type of authorization. I guess it's a type of not authorizing, right? You have IAM permissions. That's usually a service-to-service. If you're passing a signed, you can do it from a client too, a signed signature, a signed certificate. Amazon Cognito Authorizer. This is not the same as a JWT. Okay, this is kind of a custom-built thing. It's Amazon Cognito Authorizer. And finally, Lambda authorizers. These are custom authorizers. This means I can really do anything I want in the Lambda function to make sure. So if I have some type of custom thing, I can do that. If I want to do an LDAP or something like that, I can do it in a custom Lambda authorizer. That's just for REST. For HTTP, that changes up a little bit. We also do open, which means anytime you're in an API gateway, you don't have to authorize. But I wanted to show that so you have it. IAM permission, same thing. But here we do a legitimate JWT authorizer. So we can do that. You can have your known endpoint. You can have you pass your JOT token. We'll decipher it for you, and you can set your scopes and use that at the API endpoints. So you're pretty granular with that. It's really slick. And then, of course, Lambda authorizers as well. So I really encourage you, if you're writing, and I see this all the time, and raise your hand if you're a developer. Okay, almost the entire room, you're all guilty of it. Developers like, I can do it better. I'll write my own authorization system. Come on, it's been done. If that's what you're going after, that's great, but don't get lost in that when you're building applications, right? Do your authorization here, let the system handle it for you. And so you know, now I'm not saying authentication, okay? So the difference there, it's just, I'm sure you all know this, but I'm gonna say it. Authentication means, are you who you say you are? Right, so that's, you're authenticate through AWS or there's a lot of different things. Authorization says you are who you are, but do you have access to this? Right, and so you want to use the system or use the built-in stuff. Don't try to write it on yourself. There's really no need to. I guarantee you it's experts that have written this. So they don't let me touch it, if that gives you any comfort. All right, the second thing here, let's talk about caching. All right, so we already kind of covered this earlier. Amazon API Gateway actually has its own caching built in, right? And where this gets really handy is it's effective for quick responses within a region, right? You say, look, I want to cache some stuff within a region. And I guess where this really becomes handy is API Gateway manages the whole thing. In my opinion, if you don't want to manage it, this is the way to go. If you're willing to manage it, go to CloudFront. This will spin up a cluster of cache objects, and it's perfectly helpful, and it handles that all for you. You want it out of the box, that's a way to go. But there is an hour cost based on the cache and cluster size. You can get just as granular in CloudFront, but you can do it at the edge at that point. If you're caching, you may as well do it at the edge. That's my opinion. But it does do caching for you if you need it. Default throttling. Throttling's fun. Okay, anybody, all right, so a bunch of you are working with API Gateway now. Have you set up your throttling? Okay, all right, good. You can leave. You know everything we need to know. No, I'm just kidding. Okay, throttling. I'm kind of glad to see not a lot of people raise your hand. When we get out of this session, go right to your hotel and fix your throttling, okay? That's how important it is, all right? Throttling's a really interesting thing, all right? So I alluded to this earlier, as I actually said, by alluding, I mean I actually said it. You have a 10,000 RPS soft limit, okay? And that works for most people. If you need more than 10,000, I'd be interested to see what your patterns are and stuff. And it may happen. I mean, if you're like, look, I run Netflix, you probably need more than 10,000, right? But you're like, I run my mom's blog. Maybe you architected that wrong, you know? So 10,000 per second, that's a soft limit that can be raised. 5,000 is a hard limit. It's shared among all, like I said, shared among all endpoints. And I wanted to put that up here so you can see it. But this is a customizable thing, okay? So let's say we want to apply this. We can apply this to a stage. We can apply it to a resource. We can apply it to a method. It can get very, very granular. Right? So what we might do is we might say, look, I'm going to give 8,000 RPS and 4,000 to my gets in my order, okay, to orders. But I'm going to give full 10,000 with a 5K burst to my to the post of that because I want people to be able to make orders. I don't care that my salespeople can't see the orders. I want people to order, right? So you start prioritizing who gets this. Now, this is all under the umbrella of the default limits of 10,000, 5K. You can set 30,000 on your gets or posts. It won't go over 10, right? And remember that it's per API. So how you start breaking this down is you can get into custom throttling, and it can look like this. You may have a free group, and by using API usage plans and an API key, you can say, look, my free group only gets 800 and 800, 1K, 1K. So remember, I'm not going over, but I'm matching my burst because it's so low. I'm matching my burst to my request per seconds. But my people who are paying, they get priority. So I'm going to throttle my free group in favor of my subscription group. Okay? So by doing this, remember I said go home and fix your throttling. Maybe you don't have to right now, but this is just good API hygiene. Understanding the workload and the access patterns of your application is really critical. And so by understanding that and saying, look, we want to make sure we throttle a reports API that just our salespeople hit, we're going to throttle that down to make sure that a point of sale API has just all kinds of room, right? And that by doing that, you're able to probably make better use of that 10,000 RPS and your 5,000 burst. So throttling is a fun game. And you may not get it right. The other thing I really encourage you, and we'll talk about metrics and stuff in a little bit, is metrics. Get your alarm set up. Know when you're throttling, right? Set that up. Okay, so next thing we're going to talk about is stages. Anybody using stages in API Gateway? Okay, all righty. Do you love them? Okay, you do. Okay, all righty. I'm not a big fan of them. I'll be really honest. Now with some of the things, and I'll explain it in just a minute, but let me tell you what it does first, okay? So a stage allows you can have like a prod and a stage and a beta and an alpha, or you might have a V1, V2. These are great ways of maintaining multiple versions of the same API, right? So you can just, excuse me, and you can point them to different integrations on the backside based on stage variables, actually. And that looks kind of like this. So I may have a stage variable that says lambda alias equals prod. So I'll have an alias in lambda function that says prod, so it'll point to that. And then the alias in the lambda will point to a specific version. Now this gets a little complex, to be really honest. So I'm going to give you another story on that. My opinion is don't use stage or stage variables if you don't have to. Okay, there's a very good reason for them, and we use them under the hood for some different things, but if you don't have to, don't use them because they become kind of a maintenance nightmare. Instead, one, and I said this earlier, use accounts per environment, right? So instead of me supporting my dev, beta, and production all in one account, I'm going to break it into, I have developer accounts, especially with serverless, so it's all ephemeral services, right? Unless you're using a database that you can share in an org or something like that. Then I'm going to have an alpha account, a beta account, whatever. So number one, I'm getting an extra level of security that's just inherently built into accounts. Only 3 or 4 people have access to production account. They're the people that can deploy it. So not everybody has access to these accounts, so it helps lock that down, right? Okay, here's the other thing that I would use. Instead of trying to maintain stages, I would use custom domains with custom base path mapping. Okay, so how this works is I can say, I've got my custom domains, I can apply SSL cert to it, and then I can use base path mapping to build out to a V1, a V2, a prod, a beta, however you want to do, but I can point it to different accounts, or I can point it at least to different regions, or different stacks at the very least. So I'm not maintaining in the same stack a bunch of different things. This takes away a lot of management headache. Okay, and we've built this in, we have custom domains, and we have multi-level base path mapping, which allows you to just really dig that in. All right. So, earlier I talked about, and you know what, somehow, I think some of my slides got reversed, so I want to go here next, just looking at this, okay? So, this is the base path mapping that goes with logging. Or I'm sorry, how you doing? That goes with custom domains. So you can see here, I can point them to like root v1, root v2, reports, different things like that. So I may have different places I want to point them. They can be different endpoints on the backside, but still all under the same custom domain. And you can see how that breaks down. You've got your custom domain, your base path map, that's at the domain level, your endpoint map, which that's on the endpoint itself, and you can see how that combines to make a full location. All right, so let's go back. I'm not sure what happened here, but it's me, not the PowerPoint people. So let's go back to logging. So here's a really interesting thing. When I sit down with companies, before I did this here at AWS, I was a solutions architect for Rackspace. And we would go in and we'd sit down with huge companies, we'd talk about them, okay, great, and I would have the kind of story I'm telling you. And I would say, what does your logging story look like? Oh yeah, we log everything. Well, okay, that's great. What do you do with it? We log it. We log it. Okay, what do you do with the data? We save it. Drop it in an S3 bucket. Oh, that's great. What do you do with that? Well, we take it to cold storage after a while. Okay, what do you do with that? You see them get mad. We save it. I'm like, do you investigate? Do you have metrics set up? Are you getting the story from your application? And this goes back to our throttling and our caching and all the different things we're having. To keep a healthy API, you have these metrics that tell you the story. Metrics like, hey, I'm peaking out repeatedly. Or, hey, I'm dropping requests. I'm getting a lot of 429s. Why is that happening? Right? So by setting up these loggings and using the insights and using the metrics that can send out and notify people, this is really critical. So I encourage you, use the logging that's built in, you can see here the custom log formats. There's just a lot of ways you can log, but I encourage you, if nothing else, CloudWatch with metrics, and then build up on that. All right, so we're gonna jump ahead a little bit here. So next thing we're gonna talk about is canary releases. Anybody use canary release so far? All right, this is a really cool thing. A canary release says, hey, I can set this up so that while you're running to prod, I'm going to create another stage. Remember I said earlier we do things in the background with staging stuff. There's a purpose to it. I'm going to create another stage or version that says canary, and under the scenes, I'm going to route 5, 10, 20, 30% of your traffic to that. And according to your metrics, when you like it, you go ahead and say promote. And then what happens is we delete the canary, we promote the latest version to production, and you're up and running. Now here's the interesting thing here. You want to use this for API gateway configuration changes, not necessarily for code, okay? Because what happens is, this really is for API. For code, there are some blue-green things you can do with Lambda that actually happen at the Lambda function level, right? You can use this for code, but there are some other ways of doing it. But as you're making API gateway configuration changes, you're adding domains, you're adding search, you're adding whatever, you can do that using a canary. But it does require a manual promotion. So you can watch your metrics, you get a manual promotion, off you go. So that's a canary release. Like I said, once everything goes, it pops over, and then the canary itself is deleted. This is the monitoring metrics we talked about. Here's some other ways of doing that. You have Amazon Cloud, like we talked about, Amazon or AWS X-Ray, especially in serverless with distributed applications. You need the story of not just what happened here, but what happened to the same request going through. CloudTrail and AWS Config all help with that. I'm going to tell you honestly, we saw this already. I don't know what's happened to my deck, but we're going to just keep moving on. Here's logging again, so here we go. There we go. All right, resource policies. So a resource policy, this is something a lot of people don't realize they have access to. A resource policy can say, hey, only allow access to this API or this route based on specific conditions. It has to be from this API. That's how we kind of do private APIs. It has to be from this region. It has to be during this time. One of the great uses of this is, hey, we're going to do a special sale where this API is only open for 30 days. And you can literally say, make it available from February 1st to February 28th. 8 a.m. to whatever. And so you have these kind of conditions you can set that you can do this. So you see some examples up here where we lock it down to a specific account. We can lock it down to a specific IP. There's a lot of power. In a little bit, we'll see WAF. Actually, I'm going to go to that next. These are in this order for this specific reason. A resource policy is built into API Gateway. It's part of the charge. I do that first. If I don't get what I need, like an allow list or a disallow list or something like that, I do that first. If I don't get what I need, then I move to an AWS web application firewall, right? And the cool thing about this is you go into the WAF console, you can create one. You can do this all through infrastructure as code as well. You create a firewall with whatever kind of limitations of monitoring or whatever you need. And these are super powerful. And then it's just as simple as going into the stage, your production stage on API Gateway and saying, apply. And now the traffic is going to go through that WAF before it hits your endpoint. Now this is REST only, but this is especially for the financial, different things like that, super secure. So this is a great way to use WAF. Try your resource policies first, but then you can use WAF as needed and the WAF rules. All right, so a new one we have actually is we have client certificates now that we can generate client-side SSL certificates using the API Gateway. This allows the backend to verify. So you have a backend service, you want to be very careful. We say, hey, it's on the internet, it's on the AWS network, it's going to be fine. You're like, nah, I want to make sure. So you can generate a certificate and you can verify that certificate on the back end. We've done a couple other things around this. This is something we came out with in the last year, and that's mutual TLS. Anybody using or require mutual TLS? Okay, a couple of you. All right, so what this means is, normally we say, okay, as a client, when I call a server, I'm gonna verify that server through their certificate, right? That's a normal thing. That's HTTPS. I don't even know if there are any non-HTTPS routes anymore. It used to be we didn't do it because it's very expensive time-wise to call HTTPS, and we would use HTTP sometimes. Now everything goes through SSL, right? But now, if you need to verify the client, the server goes, hold on. I want to know who you are as a client. I require that you have a certificate as well. And so you can do you see here, the client required to send an X509 cert to verify their identity. This is real common for Internet of Things. If you've got devices you don't want, so these are things running without you being there, you don't want them to do that, or someone else to hijack that, they have to send a cert, and that's how you can do that. So mutual TLS, meaning both of you have to provide that. All right, so this next one, we got just a couple more here. This is really cool. This is one, people ask me all the time, how do you build API Gateway? I use OpenAPI. Anybody familiar with OpenAPI? Or Swagger? Good, a lot of you. That's where I live. I don't build in SAM. I don't build my routes in CloudFormation. I use OpenAPI for everything. In SAM, I can point to an external file. In fact, in the app composer, if you're not familiar with the new app composer, you drag things in. You can say, hey, drop this API and build it in OpenAPI in a separate file. And what that allows me to do is build that out. So where this comes in really handy is sometimes I'm not sure what that OpenAPI spec is going to look like. So I'll go into the API Gateway and I will build everything I need. Click, click, point, 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 click, 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 click. Then I will go in and API Gateway can export Swagger or OpenAPI. And I export that. And so this is really cool because now I'm able to convert Swagger to OpenAPI or back and forth. I can import OpenAPI or Swagger. I can export OpenAPI or Swagger. It's like this conversion thing. It's a great way to migrate too. I can migrate from one of the another provider, and I can import to API Gateway. And so it's just really cool way. You can also do JSON. You can do the Postman extensions. When you export it, make sure you have your API Gateway extensions, which include security, auth, integrations, different things like that. So super powerful tool that a lot of people don't know about. So they ask me, how do you build them? I build it in the console. I export the OpenAPI. So it's really easy. No, I don't have OpenAPI spec memorized. But guess what? The console does. So it becomes really handy. All right, one of the last thing we have here is identity-based policies. And identity-based policies can determine, this is more for who's building. So you can actually do, based on identities, you can allow folks, you can get really granular. You can say, hey, you can create an endpoint, but that endpoint has to be HTTPS. You can create an endpoint, but it has to be private. It has to be whatever. So this is more for internal, for monitoring your developers to make sure they're building the right type of APIs to keep your application safe. Now, I just threw a ton of information at you. Hopefully you learned something that, I didn't know API Gateway did that. One of the things that I also throw out here that I don't have on here is we have validation. Anybody using validation at API Gateway? Okay, did you know? Okay, one person. All right, so here's what I'll tell you. Validation API Gateway at the endpoint can validate your API, the incoming body schema. It can look at the schema and it can require parameters. It can require parameters that meet a certain condition. It's very powerful. So why does this matter? Well, let's say I'm running an integration, a simple integration where a request is being called and then a Lambda function is being invoked. Okay, Lambda has a great free tier. You get 1 million invocations a month. So it's like, okay, but if you're doing 5, 6, 7, 7 million invocations a month, that can price adds up. It's a fair price, but it can add up. But what if you don't have to invoke a Lambda when the incoming structure is bad? So at the API Gateway, you can say, for every payload that comes in, I want you to evaluate it against this JSON schema. If it's bad, kick it out and don't ever invoke the Lambda function or the backend integration. Super powerful tool. That I really encourage you to check out. I use it all the time. And then I make sure that when I'm doing my VTL, when I'm doing my templating or whatever, I won't pass it through if it doesn't match, so it can't be bypassed. And so it's super powerful to do that. All right, so like I said, I've thrown a lot at you. I put a lot of this in this resource, the QR code. I should have warned you before so you have to take pictures of everything. But a lot of this is in this link that you can go to. And with that, excuse me, I'm going to keep clearing my throat. The other thing is these links go to Serverless Land, the QR code you had. If you haven't checked out Serverless Land, if you're looking for patterns, API Gateway to something, Lambda, DynamoDB, whatever, we actually have SAM, CDK, Terraform, Pulumi, templates that help you get started with a lot of the stuff at this deck or at this site. If you're looking to learn more about serverless, this is we have a lot that you can do to get certified. You can get your serverless badge. And with that, I'm going to say thank you very much. I appreciate that you came to my session here. Thank you.